Hey guys, this looks like a fun one. We're given 16x factorial plus the quantity x plus 2 factorial equals 9 times the quantity x plus 1 factorial. If you try it on your own, pause it right now because I'm going to solve it in 3, 2, 1. I just thought so. I don't know if it actually works. Let's see. If you want to try it on your own, pause it right now because I'm going to solve it in 3 factorial. Because 3 factorial is 3, 2, 1. So basically, this is a good summary of what factorial means. 3 factorial is 3 times 2 times 1. You take whatever number's right here, 3, and you subtract 1 from it, 2, and subtract 1 from that 1, and you multiply them all together. You stop when you get to 1. So 5 factorial would be 5 times 4 times 3 times 2 times 1. So something like x plus 2 factorial would be x plus 2 times, and then 1 less than this would be x plus 1 times, and then 1 less than this would be x, and then you're going to continue doing that all the way till you get to 1. Or another way to write this, instead of saying x all the way down to 1, we can just say x factorial. And then this x plus 1 factorial would be x plus 1 times x factorial. So we can substitute each of those right here. In the place of the x plus 2 factorial, let's do x plus 2 times x plus 1 times x factorial. And in place of the x plus 1 factorial, let's do x plus 1 times x factorial. And then we can copy down everything else. Next, let's set everything equal to 0 by subtracting 9x plus 1 times x factorial from both sides. So now we're going to have 16x factorial plus this minus this equals 0. Now each of these three terms contains an x factorial, so let's factor out x factorial. For the first term, after we factor out the x factorial, we're left with 16. For the second term, after we factor this out, we're left with x plus 2 times x plus 1. And then for the third one, after we factor this out, we're left with minus 9 times the quantity x plus 1. Next, let's clean up inside of the parentheses. Let's copy down the 16, and then we can multiply this out. X times x is x squared. X times 1 is 1x. 2 times x is 2x. And 2 times 1 is equal to 2. And we can clean this up a little bit. 1x plus 2x is equal to 3x. And then for this last thing, the negative 9 times the x is negative 9x, and negative 9 times 1 is negative 9. And this is all still equal to 0. After we combine all the terms inside of the parentheses, we end up with x squared minus 6x plus 9. This x squared minus 6x plus 9 is a perfect square trinomial. Here's the notes for that right here. This will end up changing into x minus 3 squared. Anytime you have something times something equals 0, it'll be true if either of those somethings is equal to 0. So we can say x factorial equals 0 or x minus 3 equals 0. It might feel like 0 is the solution to this, but 0 factorial equals 1. I've made a couple of videos about why this is equal to 1, and I suspect there's probably over 1,000 videos out there explaining this. So I'm not going to spend time going over it right now. I'm pretty sure no matter how you look at it, there's no solution to x factorial equals 0. Let's see if I interrupt and make a correction. So there was no interruption. There is no value x factorial that will equal 0. And then for this one, we can add 3 to both sides and we get x is equal to 3. And that is the answer to our question. Let's check it really quick. Let's copy down the original equation, and in the place of each of the x's, let's plug in 3. Let's clean up inside of the parentheses first. 3 plus 2 is equal to 5, and 3 plus 1 is equal to 4. And then we can copy down everything else. 3 factorial is equal to 3 times 2, which is equal to 6. So we have 16 times 6. 5 factorial is equal to 5 times 4 times 3 times 2 times 1. That's equal to 120. And 4 factorial is equal to 4 times 3 times 2 times 1. That's equal to 24. 16 times 6 is equal to 96. We can copy down the 120, and 9 times 24 is equal to 216. And 96 plus 120 is equal to 216. So the solution, x equals 3, checks out. And that is the answer to our question. Let's put a box around it. How exciting. I love going through these math challenges, but sometimes if I get stuck, it'd be nice to have a math tutor give me a hint and nudge me in the right direction. And that is one of the things I love about Brilliant's new update, Koji the Private Tutor. If you're going through a lesson like this right here, you can just ask for help. Here, let me show you. So it's asking us to find the mapping that would give us a 270-degree rotation. So we're going from the blue triangle to the dashed triangle. It looks like it's only 90 degrees clockwise, but when you say 270 degrees, it's always referring to counterclockwise. So if we don't know what we're supposed to do here, how do we decide what to do for the mapping? We can ask Koji for help. You can click right here. I'm not sure what I'm supposed to do right now. Can you help me?
Where should -1 -2, move to.
Okay, so it's asking me where's this point going to? Well, I can tell that's this one right here. So it's going to the point -2, 1.
So -1, -2 goes to -2, 1. See a pattern?
So then you can tell that this y is the same as this x. So in the x place, we can put in y. Does that make sense? Y. And then for the other spot, this 1 is the negative of this -1. So that means we want to put in the negative x here. And we can see that it worked. We hit check.
Clean sweep, not one wrong answer.
And it's the correct answer. So the goal here was to help the student derive this mapping. It's kind of a great way to help a student understand how this mapping is working. And if during one of these lessons a student didn't figure that out on their own, they can just use Koji to kind of guide them along the way. I like this new feature. It's a great way to get complex concepts to click. To try Brilliant's new tutor for free, visit brilliant.org/andymath, scan the QR code on the screen, or click on the link in the description. With this link, you can get 20% off an annual premium plan. It'll give you unlimited daily access to everything Brilliant has to offer, including Koji. How exciting.